Oh, we're recording. Welcome back to the Rollin class. You know, oh, dang, I messed up. Redo it.
Okay, so we are going to continue on. So we've done our properties of equality. We're going to do our properties of congruence. So we've already actually gone through these, so there should be a little bit of a review. The reflexive property, like think about if you're looking at a reflection in the mirror, you're looking at yourself, right? So this is when something is equal to itself. So we could say for any segment AB is congruent to AB. It's congruent to itself. So it looks exactly the same on either side. Does that help? That light off? Yes. Okay, so when it's equal to itself, that is the reflexive property. That's the easiest one to find. Symmetric, we said, is when it does what? Anyone remember?
Flips.
It flips, right? Or it switches. So if AB is congruent to CD, then flip, it would say what? CD? Crazy? If I flipped it, what would it say?
CD is congruent to AB.
Good. Okay, transitive property, I think is the trickiest one. That's when we have something repeated and then deleted. That's what I like to say, repeated then deleted. It's a little rhyme. So if AB is congruent to CD and CD is congruent to EF, what is something that's been repeated there? What has been repeated there?
CD.
The CD. So I'm going to circle that. I'm going to do it in a different color. So that CD has been repeated, and now we're going to delete it, so we're going to take it out. So if both of those segments are equal to the same thing, they're obviously going to be equal to each other. So we take out that CD and just write that AB is congruent to EF. So they're both equal to the same thing, which means they're equal to each other. Alright, so those are our properties of congruence. Now, working on our definitions. Again, these should be a review. I'm going to leave it up there for you. Okay, so the definition of congruence. What does it mean to be congruent to something? What does it mean to be congruent to something? Brianna? It's the same, right? Or equal to. So if I said AB was congruent to CD, I'm really just saying that they are equal to each other. So AB equals CD. I can also write that in reverse. If they're equal, like if AB equals CD, then I can say I know they are congruent. So we're just defining what it means to be congruent. This one is also really simple to find and approve because the only thing that's changing is the symbol. We went from a congruent sign to an equal sign. So I'm going to say the sign, or let me say the symbol changes. So we're going from a congruent sign to an equal sign or vice versa. So if everything else is the same, but the sign changes, or the symbol changes, then it's the definition of congruence. Okay, definition of a midpoint. We should recognize that word midpoint, right? Hopefully, that's not a new word for us. Where do I find a midpoint?
In the
middle, right? So this says if M is the midpoint of AB, I would like you right underneath that little definition of midpoint, if you can draw what that says. It says M is the midpoint of AB. So think about where I would label my point. M is the midpoint of AB. Am I going too bad? Okay, I'm looking for your picture. Where would I put the point if M is in the middle? in the middle of A, B, right? M is the midpoint. So where would I put my point? Good. Draw in your picture. M is the midpoint of A, B. Good job, Selena.
Yeah.
M is the middle of A, B. Yes, then, so M is the midpoint of A, B. Yes? Most of us got that. M is the midpoint of A, B. So let's talk about what that means. If that is my midpoint, does anyone know what it's telling me about my line segment? Raise your hand if you think you remember. If I know I have a midpoint, it does something to my line segment. Chris? What is it doing to my whole segment there? It's cutting it in half. So do you guys remember that we marked these as congruent?
Yeah.
Okay, so let's talk about it. How would I name my first segment there? AM. I would say AM is congruent to what? Good. MB or BM, doesn't matter. So AM is congruent to MB. So the definition of a midpoint is not that it's in the middle, it's that it's splitting my segment into two equal parts. Okay, and then our last one is the segment addition postulate down here. That's again a review. That's my small part plus the small equals the whole thing. Okay, so that's all the way back from unit 1. The small part plus the small part equals the whole thing. I want you to try with your partner, maybe I'll pause the video here. We're doing something, our first small piece plus our second small piece equals my whole segment. With your partner, go ahead and discuss what I would write there. So you're actually going to fill in. How would I name my small part? How would I name my other small part? What's my whole thing? So I'm going to pause here and let you guys try that. Okay, so what I really liked is that most people had this down and no one put A, B, C at the end. Usually someone will write A, B, C, but remember we only name a line segment with 2 points. So the whole thing is A to C. So questions about segment addition. Okay, so what we're going to do is move on to this. Don't flip to the back. Find the front of your white sheet that looks like this. And let's actually go ahead and write the today I will learn. I forgot to do that. That is to identify properties, which is what we're doing. And use them. It's also there for anyone who can see that. Use them to justify steps in a proof. Okay, so I'm going to do a few of these with you. There's a property bank down at the bottom, but what I really want you to do is use that golden reference sheet that we just filled out. The segment side is what you should be on. So make sure you can see the segment side, not the English side. So you're going to go through and just identify what these properties are. Okay, this is prepping us for our first proof where we would actually fill this in a 2-column proof. But I'll do a few with you. So let's start with number 1. PQ is equal to PQ. Sorry, so what you want to look at is the if part to the then part. So from the if part, it says PQ equals PQ. Then PQ is congruent to PQ. So this is not reflexive, even though it looks like reflexive, because what's the only thing that changed from my if statement to my then statement?
The symbol.
The symbol is the only thing that changed. Very good. If the symbol is the only thing changing, look at your reference sheet. What is that property called?
Definition
of congruence. Very good. And I'm not going to abbreviate all of this because this is not English class. So this is definition of congruence. I'm not concerned that you know how to spell definition. So you can abbreviate that. Okay, I'm going to do the first 4 with you, actually. So number 2 says if K is in between J and L, then JK plus KL equals JL. We just did something just like this.
Yes.
what did we do?
Segment, addition,
yeah.
post
Very
to it.
good. My two smaller pieces add together to the whole thing. We could draw a little picture there if we needed to, but this is segment addition. So I'm going to do seg add postulate. I'm going to abbreviate all that. So do you understand what we're doing here? We're matching the correct name. So number 3 should be the easiest one. Go ahead. I'm going to just have you write it down. I'm going to walk around and see if you can identify that one. When it's equal to itself. When it's equal to itself.
Can I put RPOC?
Amy's
I want to see what you guys
This-
come up with. That someone's phone, one of my students' phone? Nope.
Wow.
Okay, so which one? When it's equal to itself. Yeah.
No, you can't.
Yes. Good.
Oh, that's okay.
Ms. Wallace, what's up? Best friend. Best friend.
Yeah, that's what you want. Nice. Yes.
That's
Yes, they can sweep you over because you now.
Alright, so most of us got this. Diego, what would this one be? Yeah, number 3.
Reflexive.
Very good. So I'm fine if you just write reflexive. You don't have to finish the rest. So just reflexive is fine there. When it's equal to itself, it is reflexive. Number 4 is the last one I'm going to do with you before I let you guys try some on your own. So we have to look at the if part to the then part. So looking at if, I just have RS equals TU. Now looking at the then part, what changed? Take a second and look at that. What changed from my if to my then?
The plus.
It got more word letters.
Okay,
The it repeated.
what did you just say, Jad?
Repeated the addition.
Okay, so she's saying we added something. What did we add to the RS?
It's
Why?
Y.
What did we add to the TU?
It's Y.
Okay, if we're adding the same thing to both sides of an equation, what is that called?
Transitive.
Think back, you can still use all of your properties of equality. If we're adding to both sides,
Addition property.
that is just the addition
Oh, it
property.
did. Oh, it did delete. Yeah.
Oh, because it's at.
Because we're adding the same value to each side, that's just the addition property. So remember, if you're multiplying to each side, subtracting each side, all that good stuff. So I'm gonna let you guys, I'm gonna put like 5 minutes on the clock and have you guys work with each other to see if you can fill in the rest of the blanks. If you're not sure about one, circle it and move on. We'll go over it. So go ahead and start.
Yes, ma'am.
Okay, so number 5, I think I saw most of us get this. Brianna, what did you get for number 5? Good, that was a symmetric
Can I remember
property.
6?
Definition.
Okay, number,
I know she recorded. Hey. I'm just saying. That's what made it bad. I asked.
Okay. So we see this word midpoint, so it is like I really liked that we were catching on to context clues. When we see the word midpoint, it is most likely going to be definition of a midpoint, which is true because we have 2 congruent parts there. Okay, what is that? Number 7.
Yes.
Number 7.
Transitive property.
Okay, calm down.
Yes, I wanted to see you get mad.
Okay. I want to talk about why this is transitive because we see something repeated. So what was repeated in step 7, Brendan?
What was repeated in step 7? Was it? It was it was like I think AB plus CD and CD was repeated again. CD was repeated.
And this, so in this, what do you see that?
Oh wait, hold on, wait. Oh, I want the wrong one.
Number 7.
It's the.
Brain fart.
In number 7, we see that one of those has been repeated. One of those segments has been repeated. Jazz?
FG.
Okay, FG is only there once. I'm just talking about in the if statement. Do you guys
Oh,
see one that's
J.
been repeated?
Okay.
So more than once. Which one do we see more than once?
HI.
HI. HI. We see that has been repeated, and then it was deleted. So that is our transitive property. That is transitive because we have that and in the middle and we have something deleted and repeated. Okay, number 8 was the one we had questions about. This one, a lot of people put transitive because they saw the CD was repeated and deleted. I like that mindset, but there's no and in the middle, so we're looking at this as one equation. So how would we cancel out those CDs, Jemiah? Good, by subtracting CD from each side. So that is subtraction property.
I would've got it wrong.
It's okay, that's why we're talking about it. Number 9, yeah, this one was a little bit tricky. So PQ plus RS, let me erase some of this stuff. So we have this whole equation, but this is the part that's really important. It tells me that RS is the same as WX. That means they are replaceable. I can plug in WX wherever I see RS, which is exactly what was done here. The PQs are still the same, the TVs are still the same. So RS is the only thing that changed, and it changed into WX. So we plugged in WX there. What do I call when I plug in? What is that? Property. Yes, substitution. So that one's a little tricky. We plugged in something of equal value there. So that WX changed from an RS because they are of equal value. We are still recording, yes. Okay, number 10. We saw that keyword midpoint. So this one should be the what? When I see that keyword,
Definition of midpoint.
is that what you're going to say?
It is.
Definition of midpoint. And I'm just abbreviating definition of midpoint. Okay, number 11 should have been pretty simple. The only thing that changed there was the symbol. Dakota, what do you think for that one? Very good. Definition of congruence. The only thing that changed was the symbol. Okay, and then the last one was a little bit tricky. The DE was over here. It's now moved to the other side, so just if I were solving an equation, how would I move it to the other side? By subtracting DE. So we subtracted it on both sides, so that's subtraction.
It's an excellent way of saying.
Not like I am looking at it.
Okay, please flip to the back of that. Okay, we're gonna try our first proof. Wait till
You try to, you got what I said, something change.
Okay, and my first proof. Does anyone remember what the first step is always? Always. We start with the what?
From the left.
We always start with the given. We always start with the given. So in a proof, we always have a given that's copied into my first step. So I see whatever's written there is also written in step 1. So the reason for that is because that was given to us. You always want to check for your given. Sometimes there's more than one. Sometimes they're in different steps. You just are like matching game. You're finding whatever's written there in the proof. So that's my given. Let's talk about what it's saying. Also, do you guys see at the bottom of your page, there's a reason bank? You guys see that at the bottom of your page, Chris?
Yes.
You see that at the bottom of your page? So whatever's there is what we're going to be plugging in. So you do have a word bank to use, which is nice. You're never going to just be given a blank proof, like on a test or the EOC. You'll always have some kind of help. All right, so it says E is the midpoint of DF. What do we think is our key word in that first step? Midpoint. So if we see midpoint, what do we think is coming next?
Definition of midpoint.
Definition of midpoint. So let's talk about it. It says E is the midpoint of DF, which tells me that my segments are congruent. So that's how I got that DE was equal to EF. So again, once we see midpoint, usually the next step is going to be the definition of midpoint. Okay, and that goes right at my step where it's telling me I have two congruent sides. So I'm going to come down here and I'm going to mark off. I've done the given and I've done definition of midpoint. So I'm just crossing them off with my word bank. Are we okay with that? Make sure you use your word bank. So what do we have left? We have addition, transitive, segment addition, and simplify. So let's look at our next step. What you want to ask yourself is what's changing from one step to the next. So looking from step 2 to step 3, what changed there? What changed? Raise your hand if you see something that changed. Jemiah?
Right?
Okay, so the EF is still there, right? Look at each side of the equation, but what changed?
Plus.
Oh, I did that. Diamond, what did you say? The plus sign, and then we added what to each side? What did they add to each side here? We added DE to both sides. Do we see that? Okay, that wasn't there before, so they've added something to both sides. What is that called when they add to both sides? Addition property. Mark that off of your word bank. One of the best things to use for proof would be process of elimination. Okay, from step 3 to step 4, talk to your partner real fast. What do you guys see that changed? Only one thing changed there. Talk to your partner. What do you see that changed? Can you just wait one second? Wait.
I think
Yeah? Okay, we're gonna move on. Eddie, what do you see that has changed?
They combine.
They combine like terms. Excellent. We had, guys, track me please. We had 1 DE plus 1 DE, and that turned into 2 DE. So that is combining like terms. Looking at my word bank, combining like terms would also be written as what? My word bank. Simplify. Good. Simplify. All right, so we're down to the last 2, which is good. So what are my last 2 options here? Look at my word bank. What do I have left?
And segment.
Good. Segment addition and transitive. Again, transitive is the one that I think is most difficult to find. So what you want to check for with segment addition is that I have the 2 smaller pieces equaling to the whole thing. So let's check step number 5. The best way to do that, look back at your picture. So this says DE. Is that my first part?
Yeah.
It says plus EF. Is that my second part?
Yeah.
Equals the whole thing DF.
Yeah.
Yeah, so that is my segment addition.
And we know the last one.
So now, by process of elimination, my last one would have to be what?
Transitive.
Transitive. Do you guys see what was repeated then deleted? Do you actually? Okay, so if I look, it's going to be, these are the leftovers of what was not repeated. So if you look for the 2D, it's equal to DE plus EF. I know that DF is also equal to that same thing. So the DE plus EF was repeated and then deleted. So that's why it's transitive. These are left over. Okay, I'm going to pause here and let you guys start number 2 and fill out as much as you can. Okay.
Welcome back.
Okay, so number 1 is always the what?
Given.
Given. I think we should have for sure gotten step number 2. The only thing that changed was the symbol. The only thing that changed was the symbol. Brandy? So what did you put for that one? Yeah. Very good. Definition of congruence. I'll do the next one. Okay, my third one, maybe we didn't know. Let's just assume we didn't know, right? Maybe you do know, which is great. But what you don't want to do is get stuck. So you can always skip around. My last step, it said that KL was congruent to LM. So therefore it must be a midpoint. We saw that key word. So what were we thinking for that last step? Definition of a midpoint. The only thing there that you want to check, it could be step 3, so you do want to look for that keyword midpoint and line it up. Okay, so KL is equal to LM. Where did we get that information from? So my last step had to be transitive, but in step 2, what was repeated there? In step 2, what was repeated? LN. So the LN was repeated, and then deleted, so that was why we got transitive. Okay, just so you know, the midpoint will sometimes line up. They'll be on the same line. Sometimes it'll be the step after. Usually it's the step after. But I like some people were moving around. Okay, last one. Do you guys think you can do it without that?
You're funny.
Okay, well, let's at least try. What I want you to do is do the most that you can do. I think you'll have maybe some issues with 3 of them, but you should be okay with the rest. So I'm going to pause here and let you guys work on that one. Okay, so number 1 is always what? Given. Okay, you want to double check. Sometimes they put the given in more than one blank, so double check always that you take care of your givens first. From step 1 to step 2, the only thing that changed was my symbol. So that was the definition of congruence.
Can I do the next one?
Diamond, I would love for you to do the next one.
Segment.
Okay, the next one did look like segment addition. But what's the best way to check that it is segment addition?
By the letters.
By the picture, right?
Yes.
So let's double check. PQ plus QS equals PS. Is that segment addition? Yeah, we added the 2 smaller pieces to get the whole. TQ plus QU equals TU. That is also segment addition. So we are good to go. Segment addition. So make sure you're always going back to your picture. If you get to a point where you're stuck, use your picture. So we're going to mark off segment addition. I think you should have been okay with the last step. So from step 6 to 7, what's the only thing that changed from step 6 to 7?
The sign.
The sign. So what is that?
Definition of congruence.
Good. So my last step was definition of congruence. So just using process of elimination here. So now we're down to substitution or transitive. So remember, transitive is when it's going to get smaller, right? We're deleting something. So which one is the smallest out of my 3? Out of 4, 5, and 6, which one is the smallest?
6.
The last one, right? So that means something has been deleted here, which we see. Those were repeated and then deleted. So transitive was number 6, which means my last 2 have to be what? Not subtraction. Substitution. Substitution, and let's talk about why, but both of these are substitution.
Oh.
Substitution is a little bit difficult to see. Substitution is a little bit difficult to see, but it's going to be in the same pattern as something earlier, just with like one thing different. So TQ plus QS equals PS. These are the same. The only thing that changed was a PQ turned into a TQ because they are of equal value. So that's why that is substitution. We're just changing one little piece there.
So you can use substitution twice.
Yep, there it was twice on our list, so that means we're going to use it twice. But what I want you to see is just don't get stuck. We can work around, and then by process of elimination, we did the last 2 are substitution. Okay, we're not gonna finish the whole rest, but what I'm gonna let you guys do, if you flip your yellow or gold sheet over to the angle side, those are already filled in for you. So what I'm gonna do is give you about 10 minutes.
20 minutes.
10, 20, 10, 20. So you have this written down. You're just going to use each other, and I promise it's not that bad. But we're going to use our reference sheet to fill in this side. So we're on to the angle. So make sure you're on the angle side of your reference sheet. The angle side.
Who's working about that?
Okay, so I'm going to pause here and give you guys 10 minutes to work through and do as many as you can on this side before we go over them. So you're just matching them to the correct angle reasons. Alright, hopefully we did okay with these. Hopefully we did okay with these. It was just kind of matching them. Maybe you just ran out of time. Number one, if it's a right angle, then it's 90 degrees. That's the definition of a right angle. Okay, number 2 is just matching it to the correct one. These are a little weird. but this was the congruent supplement theorem. Congruent supplement theorem. We don't see this one a ton, so I'm not super concerned with you memorizing that one. Number 3, what type of angles are pictured there? Jazz.
Vertical angle.
Very good. Good. That is the vertical angle theorem. Because vertical angles are congruent. Okay, number 4, it says if they are equal to 90 degrees and they are complementary. Can we see what you get for that one?
Definition of
Can we see?
definition
Oh,
of complementary angles.
Good. Definition of complementary angles. Definition of complementary angles. The next one says if they form a right angle, then they're complementary. So that is not the definition. That is the complement theorem. So these are kind of annoying, but it was just finding the correct words. Okay, number 6, we had to remember what this upside down T meant and what type of lines these are. Upside down T is, Marissa? Perpendicular. So this was definition of perpendicular. Definition of perpendicular is that they intersect at how many degrees? 90, very good. Okay, number 7. If they are supplementary, then the sum is 180 degrees. That's the definition of what type of angles?
Supplementary.
Good. Okay, number 8 says if they're complementary, blah, 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 then L is congruent to angle N. That was the congruent complements theorem. Again, we don't see that one a ton. I'm not super concerned that you remember that one. Congruent complement theorem. Number 9, if they form a linear pair, so you're looking for that vocab word. Diamond. Supplement theorem. Good. That was the supplement theorem. So the definition would say 180 degrees, not linear pair. Okay, number 10. If they are complementary, then they add up to 90 degrees. So you know what that would be. Close. Close. Complementary angles are going to be more than 1. So that's the definition of.
Definition of
Definition of complementary.
Good. Definition of complementary.
I can say that.
Thank you. Okay, number 11 was the only one that was not on your paper, but I know the girls in the back figured it out. We were adding together, it said JKM, so we're adding together small piece, plus MKL is my other small piece, and JKL is the whole thing. So when I add together the 2 parts, I'm waiting. When I add together the 2 parts to get to the whole thing, Marissa and Brianna, what did you guys get? Angle addition. Angle addition. Okay, and then number 12 should have been super simple. Number 12, the only thing that changed was the symbol, so that is the definition of what? Congruency. Okay, we are going to do one proof. So please flip to that last page. And go ahead and fill in the given and see if you can figure out the next blank.
Okay, I'm
Yeah, I got some question.
Number 1 is always the given. You guys should be writing down what I'm writing down. And recording. Alright. It said PQR is a right angle, therefore it's equal to 90 degrees. Look at your word bank at the bottom. What did we just define?
Definition
Of a right angle. Very good. Definition of a right angle. Okay, number 3 kind of came out of nowhere, right? So we want to double check with our word bank and double check with our picture. So PQS, is that a small part or the whole thing?
whole thing.
whole small part.
Small part, PQS, SQR,
This funny
SQR is another small part. And then together they equal PQR, which is the whole thing. So what is that called when I'm adding together the two pieces?
Angle addition.
Angle addition. Look at your word bank down there. Okay, number 4 says they are equaling 90 degrees. That came from an earlier step. So maybe we're not sure about that one right now. So let's look at the last one. We said if they equal 90 degrees, then they are complementary. Look at your word bank. What word did we just define? Look at your word bank, not me.
Definition of angle.
Good. Definition of complementary tells me if they equal 90, then they are complementary. So my last one is definition of complementary angles, which means look at your word bank. What's the only thing left?
Transitive.
Transitive. So transitive was repeated and deleted. So we saw that these were, or PQR was repeated and deleted. Alright, those are notes, so you may put those up, and I'm going to pass out your prep work, which is or Brenda's going to pass out your prep work.